are borrowing everything. Okay, so yeah, like I mean, before before ES6, right? There was no classes in JavaScript. You want to create you want to create an object in JavaScript using a constructor. You have to use constructor function. This is what you use to create functions in JavaScript before the this keyword. Sorry, before the classes came about. I don't know what I'm trying to say. Yeah. So they had to borrow stuff and then you know. Okay, so now this is I think rule five. Rule five is one of the rules I've talked about before. Okay, so now they said JavaScript determines the value of this at runtime. This is what I'm trying to explain. So the value of this is undefined until runtime. So based on the current context, so this can sometimes point to something other than what you expect. Hmm? Sorry, I can't hear what you're saying, though. But okay, so JavaScript determines the value of this at runtime, and then based on the current context, this can sometimes point to something other than what you expect it to point. Right? Consider the following example: cat class with method called make sound. Right? Following the pattern for with the constructor function with the new keyword. So now we expect that okay that this should point to right. Okay, so now this dot name should point to this dot name and this dot sound to point to this dot sound, right? Using because of the new keyword. So that's basically what it's saying. It's saying that um it's only at runtime that you can actually determine the value of this, which is basically why we get what's going on here. That means this cat is pointing towards this function, and then this value, this of fat, this fat daddy, and what's this meow. This is pointing towards this sound, and this is pointing towards this sound. So now let's. This is clear. This is basically a very very easy one to understand. Like this is what we're talking about. But now let's look at something different now. Now let's try to give the cat a way to let's try to give the cat a way to annoy like an annoy function. Annoy people by repeating his sound 100 times once every half second. So now we are now okay. If you notice now, what's going on is that we have a function. Okay, let me just copy this so that I can use it to explain. Maybe that might make more sense. I'm just gonna remove this one and this. So now, if you notice now, this is um this to annoy, right? Is there is a set interval here, right? And then there's another scope here. Can you see? A function scope. Who can remember what we said something about having a function inside a function? What the scope would be? Who can remember? We did something like that one time. I taught you guys about eh? Yes, I did. I did. So what you guys have forgotten. Try. Yes, yes, it was one of the first. No, that's not what I said. I said when you use a function inside another function, it distorts the this. So that inside this particular function now, this is pointing towards the global object. And then there's no this that make sound on the global object. That was happening here. I explained this in very well that day. Like I gave you guys like very solution. So I don't necessarily wait to forget that thing. Well, so now this does sound make sound is not defined because of we have a function inside another function inside an object. So there's a problem now. So So this doesn't work because of the certain because in set interval callback, we've created a new context with global scope. So this no longer points to the our kitty instance. In a web browser, this will instead point to the window object, which doesn't have a make sound method, right? So one of the ways that we can change the value of this is to point this don't make sound to um this function here. So we can use this don't make sound dot core. We can bind it to this. So that's one of the ways to do it. Or better still, what this guy is saying is that we can also store the value of this in a variable, right? And call it self or whatever. You can store the value of this. You can say, okay, whatever this is, store it in a variable. And then that's what you are using to reference make sound now because this particular one is going to point to this object here. This object, this one here, this guy here is going to be able to access this guy inside here. So this guy here can access this variables outside here. This self or this guy can access this method here. So that's why we're storing in a variable here. So when we are saying this, we are saying that the method here that we can access dot make sound. I don't know if it makes any sense. Does it make any sense? Let me know. So that you're not getting it. Okay. So how do I go this thing again? Because I know I explained this thing. Yeah. 95. No, 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 it's not the same thing. What I said here is that at this point here, right? Okay. At this point, we have let's say new this. Let new this is equals to this. So what this means is that I have access to the this yeah the this here now this eh this one it is the same this here. Okay, at this point here, if I remove this, okay, let me just move. Let me try and remove this. Let me comment this out. If I do if I do this dot make sound, is it going to work? Am I going to get a very an answer if I do this dot make sound here at this point? Hmm? No. Are you sure? It will work. You can access it now. Eh? Okay, wait. Let me see. Let me see if I can. Let me see if I can. Okay. How do I show you guys this now? Now I'm thinking about it now because I need to be able to call this down noise. Okay. Okay. Let's see what happens. Let me see if we can play it. If I want to get an error. I get father this is emerald. This that means this works. But let me also say okay, so yes, this works. If you can see, if you can notice it works. I can actually access this object inside this object here. It's the same thing now, guys. I don't know why this is sound. This is strange. It's like saying this dot make sound is equals to a string. Let's say sounds, and I'm coming here to say in this function. Sorry, in this yes, I'm going to say okay, console log this. I'm trying to call the function. This one make sound here. What would I get? I'll get the sound now, right? The object is not encapsulating this second object. There are two different objects. I hope you can see. This does make sound is an object. Yeah, sorry, it's a function. Yeah, so there are two different functions, but the thing is, they are not encapsulating each other. So obviously, this one will be able to get access to this particular function or this method. Well, I don't know. I don't know if this is making any sense anymore. Okay. Mm-hmm. Any yes, that's what I'm saying. Sis. Yes, yes. Not inside it. Ah, I know that's what's confusing you guys, but don't worry, it's not inside it. It's outside. So at this point now, we can actually get the value of this guy here, and we'll console log guy to show when we associate this um method. When we associate the object. So when we do this do annoy, getting do annoy is going to console is going to call this because this is visible. But the problem now is that we now have another function inside this annoy function, which is what is going on here. So now I want to access this door make sound inside a function that's inside another function. So now that's where the problem is now. So at this point now, we cannot access our this, which is this one here, with this in this global scope inside this place. So now that's where the problem is now. Is that making sense now? Are you guys getting it now? Okay. So for us to be able to do it, we can use um uh, this don't make sound no dot call. We can use so we can use call. Um, okay. I don't know. I have to mind them. Quite noisy. So yes, so one of the ways that I will just show you guys now is you can actually just do you can store the value of this in a variable, right? So that's where you can actually now access it. Like you can use something like new this. That's what they did here. That was the solution here. So now at this value, now this is pointing to is a stored value, right? You're saying okay, store this in a variable, and then I'm saying okay, this is accessing that value here. So now let's work. If I try to call it here, it's going to work. That's what that's what that was done here, right? Um, let me see. Where is it? Where is it? Okay, yeah, this is it here. So where the study value of this in count in self, right? And they were able to bind um a whole. Are you serious? Oh, so what I was saying is the solution here, right? One of the solutions I can use is to store the value of this in a variable, right? And then you can actually use that value to call your methods because of your function inside another function. Another way to do it is to use an array function. So when you use an array function, you don't have this issue. I can remember now. Talk about array functions. How array functions take this of their parent. So you can just do this, and this would point to this that I wanted to point. It's breaking. So sorry. What I'm saying now is you can also use an array function to do this, and this array function is going to the value here is going to point to the actual this of the object. Does it make sense? Am I still breaking? Ah, okay. Sorry guys. Network. Blue has said to not be nice. So what I'm saying is um the array function, right? It it modifies this to the point that this initial array function is the one of the object of the global object. Does it make sense? Okay. So what I'm saying is another way another way to I beg now you guys should pity me small. I'll also be done. I beg. Okay, so uh please now you guys should please. Okay. So yes, can you guys hear me? Yeah. So what I'm saying now is yeah. This another function, right? Especially when you have a function inside the function, you can the other function takes the this of the surrounding scope. That means the function the scope of this cat now can be accessed inside this set interval function. So it cannot be done with a normal function. Right? When you have a function inside another function, in a normal function you cannot access the this. But with another function you can. Does it make sense? You can access this inside this set interval using an array function. Does it make sense? Okay. Okay, so now let's look at what they said. According to them, they said um with CSS you can avoid assigning this to a local variable by using an array function, which bind this to the context of the surrounding code where it's defined. So this is these are the five rules of this in JavaScript. So with this you can understand this in JavaScript. I've said this more than 10,000 times today. Okay. So is there any rule that you don't understand? Is there any rule that I should go through again before we hop on what so there are five. Yeah, yeah. Okay. Mm-hmm. Mm-hmm. Yeah. Your analogy is something that I don't even understand because okay, if that's like I understand it then no problem. I don't understand it that way. I don't know what prison is with JavaScript. I don't know why I'm bringing JavaScript and prison together. Okay. So now let's look at something more. So this is an article, right? And this article is very, 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 very good in explaining how the projection um objects, right, to like everything that object contains. So this introduction is very, very, very detailed, right? So let's say so basically it starts with what are objects. Objects are key value pairs, right? The most common way to create an object is by using curly braces. I can add parameters and method to them using dot notation. This is very clear. So yeah, this is an object, right? Let animal, and then we can declare in that let animal dot name is equals to Leo energy, and we can also add methods to it, right? We can do animal dot eat, animal dot sleep, animal dot length. So is this making sense? Do we get what we like all these things here? Is this what is going on here, or should I still like explain what is going on? It doesn't make sense. Does it not make sense? Okay, I will try my best. Okay, this particular rules one. Oh, all right. You guys should enjoy. Okay, so this is first one, and the second one is this one. At first glance, this second material might not make sense. So let me warn you. As you are going through it, just don't expect it to make sense on the first time. Maybe the third or the fourth time. The first time, I don't think so. So we have an object, but maybe after the class when I after my explanation to make more sense. So after the okay now let's do this now. Let me comment out all this stuff. I move everything here. I move all this stuff. So when I create an object, right, in JavaScript, right? Creating an object is in JavaScript is like select animal, right? We want to create an animal object, create an object. But it's an empty object, right? It's empty now, have you? Can you guys hear me? It's empty. Yeah. So and that's not a bad thing because empty objects are normal in JavaScript. But we want to be able to add properties to these objects on demand. So we can have animal.name, right? And then we have the name. So when we console.log animal, we'll see the animal object. See that the animal object is name and energy, right? We see name of Leo, energy of 15. So you can also add methods to it. Animal.eat. Animal.eat is equals to you can have a function, right? This is a function. So function amount and the console log this dot name is eating this dot energy is an amount energy plus amount. So basically what this is saying is that this animal dot eat, right, is a function, right, or a method, and then when you call this method, right, you're meant to pass in the amount, right? So when this console log this dot name is pointing towards the name of this object, which is Leo, right? Right? Do we get? Yes. So if I console log will say Leo is eating true or false, and then this was energy is because the energy which is 10 plus the energy that we're going to pass into this amount, which is let's say animal dot eat. We'll pass in a amount to be 10 or let's say 20. If I play this, See, Leo is eating. But we cannot see the energy here. So, but when we do console log animal do eat. But this night, everybody's just making too much noise. God I beg. So when I play this, I get that animal Leo is eating and the energy is 30, right? So it makes sense. We understand what's going on here, right? Like, I need to know if I continue. Are we good with this? Does this make sense? Hello. Yes. Animal energy is this starting now. You know why it's starting now, right? Okay, let me change this again to 15. Makes sense. So are we good now? Does it make sense? Okay. Okay. So now the same thing with this animal or sleep. This is another method you can add. You can add like we have three methods that we're adding to this particular so this is taking a length and then it's going to take in it's going to add the length to the energy. So this particular energy is going to add it to so and this other plane is going to add this particular one to the so this one is going to remove this length is going to remove from the energy, right? So yeah, so simple. So now odds are in our application that we will need to create more than one animal. So there's actually a time where we might need to create like let's say um different animals instead of just only one and create let's say 5 or 6 animals. Is this the most optimal way to do it? Let's say you want to get an animal and the animal name will be let's say let's second animal. Then we'll now have to do this again. Um second animal the name, second animal the eight. I beg, is this optimal? Guys, is this optimal? It's not optimal, right? It's repetitive. It's very repetitive now. Abi? It's very, very repetitive. This is not the best way to do it. There are better ways to do things like this. Okay, so in our application we will create more than one animal. Naturally, the next step is to encapsulate that logic inside a function and we'll invoke it whenever we need to create new animals. So we'll call this the pattern function instantiation and we'll call the function itself a constructor function since it's responsible for creating constructing a new. So basically what this guy is saying is that we are going to put this we're going to wrap everything inside the function now. So now this is what we're going to have uh, um, instead of having to duplicate our code, right? So we're going to have one function. Function is going to create all it's going to contain all these variables here that we're spending our energy to do, right? We're going to call the function animal. So this function now is going to contain this variable animal, right? And then animal dot name, animal dot energy, animal dot eat, animal dot sleep, and it's going to return animal. So whenever we whenever we call this let's say we say let dog is equals to we'll now say animal and then we'll pass in the two variables which is the name and energy. The name should be let's say Leo. Energy should be let's say 30. So when I consider log dog, I should get an object. So the name is low, energy is 30, it is so yes. Does this make sense? Oh, is it clear? Does this make sense? How we got to create this? Okay. So now we see that you can use functions to do this now, right? So it's way better. But is it the most optimal? Answer is no. This is not the most optimal. So, but this is one way of creating objects. It's called functions instantiation. It's one of the ways to create objects in JavaScript. It's one of the object-oriented programming patterns. So it's something we call in JavaScript. Something called design patterns. I don't know if you heard of design patterns before. Have you heard a word for design patterns? Anybody? So design patterns. What are design patterns? Okay, so yes, design patterns can also be for designing, but also can also be for programming. In programming is the way you is the ideology at which you use to create things. So I want to create, I want to use a pattern to create something. It's like saying there's a mold. I put something inside the mold and I'm getting something outside. So the pattern at which I formulate my code is my design pattern. So now this particular object is formulated using functions instantiation. Where is it again? Where is it? Yeah, this should be it. This particular object is so we call this pattern. We call this pattern of creating objects is called functional instantiation pattern. That's how we one of the ways we used to create objects. But that's not the only way. There are other ways. Okay. So now we are talking about functional instantiation with shared methods. What does that mean? It means that you want to be able to have one object, but you want to be able to share it with your different functions. Okay, let's read through so I can get what I'm saying. Well, whenever we want to create a new animal, or broadly speaking, a new instance, all we have to do is to invoke our animal function, passing it the animal's name and energy level. This works great and it's incredibly simple. However, you can spot any weakness in this pattern that the biggest and the ones that will attempt to solve has to do with the three methods. These three methods, right? Each of which method are not only dynamic, but they are completely generic, which means that there's no reason to recreate these methods as we're currently doing whenever we create a new animal. So if you will know that in JavaScript, when you create a function, right, all these variables are always recreated every single time you call this function. But do you need to always create new variables? So if I have three animals, like let's say I have animal dog, animal rat, and animal chicken, that means every single time this object is recreated. Is it optimal? The answer is no. It's not optimal because there's no need. It's not necessary to recreate this object every single time you call this function. This object is created from scratch every single time. It's like saying I'm having three different objects, so there's no point in doing that. It's not the best thing to do. Okay, so we're just wasting memory and making each animal object bigger than it can be. So that's basically the problem. The problem is that we're wasting memory because we are basically storing, we're creating every animal afresh every single time the function is being called. So what if instead of we creating these methods every single time we create a new animal, we move them to their own objects? where each animal has reference to that object. Right. So this is a solution now. Um, you can call this pattern functional instantiation with shared methods. So it's very wordy, but it's descriptive. Functional instantiation with shared methods. What that means is that you can create an object, right? The object contains all the methods inside: the play, the sleep, and the length. And then now, what you're doing is that you're saying that every animal dot name, right, is going to be so animal dot name is going to be name animal dot name. So but animal dot eat is going to say animal methods dot eat. That's this method. This one is going to be given to this guy. So now every single animal you create now is going to just going to share from these animal methods, because the amount, the length, and the play, they are very very generic, right? So does this make sense? Or should I see you explain? Okay, we played. Okay, now let me explain again. Now instead of us having to recreate our object every single time, we created an object outside the function. Remember, whenever a function has an object inside, this object is always recreated every single time the function is being called. But this particular one is not being recreated every single time because this particular object is outside function. Does it make sense? So this object is created only once when the function runs. When the code runs, just create this function once. But this object animal is recreated every single time this function is being called. So this one is called animal Leo, right? It's created. This object created one. Animal Snoop. This object is created again. So, but now we are saying that instead of us having to recreate this particular animal methods, is there a way we should not waste energy and resources? Just create it once. That's what we're doing here. So animal.name is taking this name. Animal.energy is taking energy. Animal.eat taking this animal.eat method, right? Animal.sleep is taking the animal.sleep method. Animal.play is taking the animal.play method. So when we consider log view, so when I play this, so when I play this slope, I can see the energy, the eat, the sleep, and the play, right? So can we see? Does it make sense? The amount. Can you see? So the eat animal or eat is is taking the amount. So animal or eat is taking the amount. So the eat is a function. So but we've not called the function yet. So when we call the function, right? We're going to be passing what happens now? What's to it? Yes, yeah. So we can do snoop dot eat. Then it is going to take in an amount which is, let's say, 500 or 400. Then let's consider log snoop. Okay, so let me play this. So snoop is eating, right? And then getting energy be 410. Can you see? So now the object has increased. The energy has increased from 400 to 410 because we're passing an amount here, right? So does it make sense? Okay. Okay. So now let's move on now. because this is one of the ways to do it, but there are other ways to do it. Okay, so by moving the shared method to their own objects and referencing these objects inside an animal function, we've now solved the problem of memory waste and overly large animal objects. So now let's look at another way to learn. So object of create. Let's improve our example once again by using object of create. Simply put, object of create allows us to create an object which will delegate to another object on failed lookups. Put differently, object of create will allow you to create an object, and whenever there is a failed property lookup on that object, it will consult another object to see if the other object has the property. So, does anybody know what this is, or should I explain? Okay. Now, let's start with this now. This is an object. Let me copy this object. Now, our topic is quite very elaborate, yeah, but okay, let me just. Now, this is an object. This is the parent. It has a name, age, and heritage, right? But I'm creating a new object called child, right? From this parent object. So object of create is saying create a different object, a new object from the parent object. So if I console or log, let me console log child now. I'm going to see that. If I console or log child now, let's see what child contains. Child is basically okay. Child is a child should not be an object. I'm coming. Let me play this again. Let me save this. Okay, so child is an empty object, which is quite weird. But thing is, we are creating an object from an object, right? We are saying create a different object from this particular object. So this is what we're going to use to create the object. So now that we have an object, now we cannot do something like this. Child.name is Ryan. Child.age is 35. Oh, sorry, it's 7 here. So let me comment this one out, and then we'll save it. And then let's play it now. We'll see that child is not defined. What's going on here? Child is not defined where? Mm, what's going on? Let me save this. Um, save this. Okay, yeah. So now we see that we have an object, and then the object, the name is Ryan, right? And then the age is 7, right? So, um, so you might be asking, what's the use of object to create, right? Um, does anybody asking the use that? Why can't you just create an object? Like, why using object to create? Does anybody have that question? Okay. Okay. So now, um, we we have this object to create, and we have the name to be Ryan and age to be 7. But what if we try to something like object dot heritage and we save it? We play it. Object of heritage is Irish. Can you see? The thing is, what this is saying is that you're actually creating an object using another object. That's what this means. It means use the first parent object to create it. That's why the name parent and child. If you understand, that should spark a form of at this idea. The parent object is the parent and the child object is the child. But the child object can access properties from the parent object, right? So if I don't have a child dot name here now, child dot age, and I consider log, I command this one out. Uh, you can tell me what the child dot age will be. 35. Yes, is a copy of the parent object. Exactly, it's a copy of it. So now, that's what this means. The child object is a copy of the parent object. That's what object of create does. So this, in this example above, because child was created with object of create parent, whenever there's a field lookup. So the thing is, whenever we search for heritage on the child object and we cannot find it, we are going to have a backup, which is the parent object. So you say, okay, search in the child object. If you want to find it, check search in the parent object. So if you want to find it in the child object, it will go to the parent object to look for it. And then if you can find it there, to give you your console. But if you want to find it, then there will be an error. Does that make sense? It's only just that understanding of this class because I think everybody should be. Everybody, are you guys are you learning? Is it making sense? You follow. Samuel, is it making sense? No, Samuel. Lekon, are you there? Israel. Israel, Lekon, Samuel. Are you guys there? Eh? I can't really hear you. Okay, so now that's what this means now. The child object is the copy of the parent object. So now I'm sure now if you read through this whole big grammar again, you will get what this guy was saying. Let's let's improve our example by using a code of create. Simply put, code of create allows us to create an object that will delegate to another object on failed lookups. Does this make sense now? Exactly. So yes, that's what exactly was going on. Why it's going to work is that every time there's a field lookup on object of the child, it's going to check in the parent object to look for that particular property. Object of create would allow you to create an object, but whenever there's a field property lookup on that object, you consult another object to see if that other object has the property. It has lots of words, so that was basically it. So functional instantiation with shared methods and object of create. So now we have our object here, which is our shared method, right? So we want to share. So I want to share this now. This is the method I want to share. Animal methods, and then we have a function animal. Then the animal is look at if you notice now, animal dot. So normally before what we did is that we actually have a this is what we used to have before. I'll just copy this too, so you can see the difference. So look at them the difference between these two. Okay, can you notice the difference between these two functions? Okay, on the shorter. Well, that's not actually that's not the benefit. It's yet the shorter, but one is not. This is an empty object. If I want to look for, let's say let's say this particular guy needs to add let's say animal to play, right? And I come here and I play, I make a I do let animal because to let's this If I check, if I consider log this loop, am I? Do you think will I see the play method on it? Will I be able to see the play method? Not there. But here, will it be here? This girl, Sha, they always amaze me. Oh. Amazement. Okay, yeah, you are very, very correct, actually. You are very correct. So, that's what's happening. This object of create is going to create its animal using this object as its prototypes. So, when you do animal.name, now you want to override the animal.name, animal.energy, right? But every other thing, all the methods, the play, the strength, and the eat, just see the same thing. So, when I do this, you console log snoop so I can see. When I play this, you see that uh, Snoop. Okay, Snoop is very very modest. He has just name and energy, but I can also do Snoop dot play, right? And I pass in the length. Let's see of 20 and play, and you see Snoop is playing, right? So now that works. So now let's call leo.it, right? And then we'll see that we can look into the it method, the object, the lookup will fail. Then, because of the object of create, it will delegate to the animal methods object, which is where to find it. Right. So this is perfect. So so far there are still some improvement that we can make though, but it seems like this is quite. I think this is neat, right? Animal methods in so so this is it just seems a tidy hack, right? To have to manage our separate objects in order to share methods across instances. This seems like a common feature that you would want to be implemented in language, in the third language itself. Turns out that the whole reason this that's turns out that's the whole reason why you're here. So now we're looking at, is there a way to, instead of having to create a different object every single time, is there a way to use an already existing object that does exactly the same thing, and the object is the prototype? So in JavaScript, every function in JavaScript has a prototype property that references an object. So now, if you look at this function, do nothing now. This is a function. It's not doing anything now. The function has a prototype. So you can always do something like this. So if two things that this object has two things. Number one, it has a prototype and it has a constructor. Let me show you. So now, let me take this to my browser, and I would open um so let me play this. Um, if you see this console log do not in the prototype, you can see the constructor. The constructor has the constructor, which is do nothing, and has a prototype, which is an object, which is object dot prototype. The constructor of every function is itself, which is the constructor of self. Do nothing. The constructor of this function constructor is do nothing. In JavaScript, functions create themselves. Like they are constructors, except if the function is constructed by something else. I know this is quite crazy, but this will make sense later. But let's forget about constructor for now, sha, and let's look at the prototype. So the the prototype of this particular object is a prototype, just a prototype, and the prototype has different methods. The prototype is an object. The prototype of this function is an object. I don't know if anybody get what I'm trying to say. I feel like I'm talking to myself. I swear to God. I guys, it's
You're not talking to yourself.
making sense. It's making sense, right? Is it making sense? The prototype is another name for creator. Let's say blueprint, like a person that, how do I put it now? Okay, a prototype, what a prototype is in JavaScript is a place, right, to store shared methods. If you look at this is has-on property. Has-on property is a method that is shared by every single object in JavaScript. To string every single method, no matter how many strings you write, they will have to string, right? So this is a way to ensure that JavaScript can share properties. So imagine if I create an array today now, I say let ERR is equal to this. My house is 0, 1, 2. And I do something like a ARR dot pop, right? And nothing happens. Or it tells me error, syntax error or whatever. Will I not be worried? I know this exactly because but imagine all arrays in JavaScript share these properties. That's why the prototype is basically a place to store things that can be shared by different um, data types in JavaScript. So you can add to this. You can basically create a prototype, right? And then the thing is, when you create this array, right? Um, when you create another data type, JavaScript does something. It if you try to create, let's say you do array dot pop now. JavaScript will look for this in this array. Is there any pop in this? It's not going to find any pop in it. It's going to go to the parent, the creator of the array, which is the object, the array. And it's going to say, do you have pop? You're going to check there. If that one does not have pop, it's going to go to the next creator and say, do you have pop? It's going to keep going, keep going, keep going till it finds pop. These are the two benefits of prototype is ability to share methods. So now you can create arrays and have pop on it. Second thing is um, the sharing, and then is also field lookup. So when you look for something and you cannot find it, you keep going to the next one, to keep going and keep going and keep going till you find it. Does that make sense? Anybody don't understand? Does anybody don't? Okay. Mhm. So if you store, if I say this is prototype and I say it should be equals to let's say I add something, let's say I do something like this now in the prototype dot it, right? Have a function. What this means is if somebody comes to this prototype now and tries to call it, right? and the prototype, let's say, or what kind of analogy can I use now? Uh, if somebody like tries to look for it in this object, this something, I cannot find it. This function would delegate it to say, go and search in my prototype. You can find something there. Prototype is like storehouse. It's like place to store things. Do you understand? So if I want to look for something and I cannot find it here, the first thing to do is to go to the prototype and look for it. If I cannot find it in this prototype, I will look for the prototype that created this particular something. And then the prototype that created that one too. This prototype. So sometimes you can have up to 10 different change of prototypes. Like different creator. Like now if I say let parent equals to an object, have a name equals to one. And I do something like let child one is equals to object create. I say should create from the parent. I can still do let let child two equals to child one. This is possible, right? Now this, if I have child 10, along three is manual labor. Let's stop at three. Say child three now is an object, and I'm trying to do something with it, and I cannot find properties on it. It's going to go to child two to look for the property. If I don't find child two, it's going to go to child one. If you don't find child one, it's going to go to the parent. If you cannot find the parent, it's going to go to the parent prototype. You guys, it's going to keep going till it gets to the form, the creator of everything, which is object prototype. 278 285. What happened to them? Okay, that's an error now. She gets that. Mm, this, okay. So now let's move on. I think we worked on this for quite a while. Okay. Okay. So so instead of creating a separate object to manage our methods, like we did in animals, this animal object that we created. Before we created an object, this animal object. This one here. This is what we created to manage um our methods, right? We can just put each of these methods on the animal function prototype. Then all we would have to do, instead of using object of create to delegate animal, we can use we will use we will use we could use it to delegate animal the prototype. We call this pattern prototypal instantiation. So what this means is now we have um we have our function that has animal, and then we create an object of create animal the prototype. So this object of create is telling us that the parent of this particular animal is animal, this animal the prototype. I mean the prototype of this animal is the parent of this small animal here. Does that make sense? Okay. It's just come down, don't worry. I'll try and explain it to the best of my abilities. Function animal is the creator, is the constructor function, right? And takes into parameters, takes in name and energy. But we want to create an animal, right? Last time we did what we did before was this. Right? Let me comment one out. We did this. Animal is because object of create animal methods. If you can remember. So this was so we are basically saying that let this object be the parent to this animal. But now the object that we are pointing this our object of create to is the object that is attached to this function. So now this function has an object attached to it, which is prototype. So we don't need to create another function outside to manage it. We can basically use the function of JavaScript already given to us, which is the prototype function that is inbuilt inside the function itself. Does that make sense? Yes, which is the prototype object. So the prototype that is attached to this function, right, is an object. We cannot say animal the prototype is animal because animal is not a function, not an object. This is not an object now. True of us, it's a function. The function that we are talking about now is the prototype function. That's what we are using to create this animal. Now, for us to be able to access properties in this, just like we did here, we now have to start adding elements to the animal form. So animal the prototype, but it with this function. So now, this animal the prototype has a a method. Is it. So now when you're creating this animal the prototype, when you're creating this animal from owner, now there's a method to work with. Now there's a method to work which is it. So now if I consider log, if I turn this animal, I'm going to get the name, right? Um, I'm going to get the energy, and I'm going to also be able to access it. But remember, the it is in the prototype, so I should not be able to see it normally. So let's consider log. Let's create an animal so you can see. Let's do animal equals to um animal. I'll pass in the name, or let's say zebra. Energy is 11. So your log new animal. Save it. I'll play this. Now we have new animal to have a name and energy. Can you see? Can you see that it is referencing that it is created from the animal, and it's saying that it has a name of zebra and energy of 11. But in this new animal, I can do dot it. I'm passing a method to it. Let's say it. What does it take? It takes amount. Let's say amount of, let's say 12 into save it. So log new animal. Save it. I will play this. So now I have zebra is eating, right? I'm undefined, and I get animal to have name and zebra. So now I can see that I can access this it from this new animal because I added it to the prototype of the animal prototype, and I'm also creating this animal object using the animal prototype. Does it make sense now? Is this clear at all? Anyway, any manner. Ah, God, I beg. Josh, you're like I didn't want in this class. So that person is just. I guys actually don't listen. And you are not. You guys are not. You are not. Are you following? You're floating because you're not talking. That's why you're floating. You are moving, moving. You are still there. You should also ask, wait, what's going on? Interact with it. So we know that what's going on. So you're actually picking up. So you're floating now, Joyce is getting it. God. Okay, Joyce, let me hear. Can you explain what I just explained now? Just explain it. Let me see how deep you actually understand what I just explained. Mm-hmm. Yeah. Okay. Yeah. Mm-hmm. 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 Okay. Okay. You tried, but let me correct something. You cannot actually see what's in prototype. You can't see it. It's not possible to see it. You can use it, but you can't see it. Like it's not going to show here. You will not see any it method at all. There's no way to see. No matter how you try. But yes, yes. You see, it's because it's not going to search. It's going to search here, but to not find it. But to now say, okay, what is your prototype? And it's going to say my prototype is animal the prototype, and it's going to search, okay, is there a method called it in animal prototype? And then you're going to get yes. Okay, take the value of it and do whatever you need to do. But you still cannot see it outside. If you control log the animal, you won't be able to see it. But when you try to access it, yes, you can access it. Yes, yes. That's what happens. You can't see the yes. But the it function is there. The same way when you console or log an array, you have let's are so is equals to exactly. Let's say you have 0 3 3 5. I console or log here are two. You can't see pop, you can't see split, you can't see splice, right? When you put a dot, you can see them. These are showing here dot pop or filter, they reduce them. But they are not showing when you console log the array. You will not can't see them, but you can use them. Okay. This is actually the building block of JavaScript. Like this is the once you can understand object-oriented programming, you will know how JavaScript was actually created. Like what was going through the guy. Was like, what was this guy's mind was missing? Actually, you can see because what we are dealing with now is called design pattern. Design pattern is how was this language designed? What was the creator? What was in the creator's mind when he was designing this thing, creating this thing? So when you can understand design patterns, you will know okay, object OOP is a pattern of designing a programming language. So if I want to create another programming language, let's say tomorrow I want to create my own. Let's say my own should be um Tonzi or whatever. Topic or whatever. I don't know. I can use a design pattern That's object oriented programming. And how do I use that pattern is by understanding, by using objects to create things, to assess things, to have prototypes where I can store things. So that way I can, that way tomorrow you can see somebody can just wake up tomorrow and create his own programming language. It's because of design patterns and because you know how to design it. This when you understand this kind of things, you can easily just wake up tomorrow morning and create your own and call it whatever. So, but our advice if you want to create your own programming language, you should go and learn C or C plus plus because that's actually how they created Python and JavaScript. They both created from C and C. I think C. So yeah, that's but I don't think there's any need to create your own programming language. Yeah. If you don't, if there's no problem you're solving, you want just want people to. Okay, so now hopefully we had a big moment again. Prototype is just a property that every function in JavaScript has, and it is so above. It allows us to share method across. So we've not even gone half of this material. Oh, and my battery is about to die. We still have a long way to go. So yeah, we have a long way to go. So we might actually have a part two of this. Oof. So now we're going into the. Hmm? Should we stop here? Yeah, and it's very very detailed. Like this is one of the best things I've seen on OOP so far. Like it explains every single thing that goes on in OOP. Like how step by step to like it's like a chronological sequence on what happens. So I would have loved to take everybody through because I think once I'm explaining it, it start making sense on what is going on. You know, I can actually make it on that. I can do when you see when I explain it when I'm done explaining it and you see what you see it you probably be, okay this is okay this is what is happening. So that's why it's good to attend stuff like this where I'm actually explaining to you. Because if you try and go it on your own, you can actually read this article for 5 times and you will not get anything. I bet you. But when you come and you listen to me explain, so I don't know. Should we stop here? I think we should stop here. Yeah, it goes deeper actually. It goes deep, deep. But hope you guys have been able to learn something today, Sha.